Floor is yours.
No, no. Okay, so first thing I guess I should do here would be to share a screen so that y'all can see it. I have two terminal windows open. I cloned a GitHub site. Does anybody want, or does anybody not have and want the URL to download the sample files?
You go get started, but and I'll post it in. It was in the email I sent around. So
Okay, um, so anyway, before we start looking at actual code, although I suppose I can put this guy up here, um, I created this little GitHub repository. I pulled the regular expression stuff out of an introduction to Python class that I taught, what is this, 2025, 12 years ago, which frightens me no end that 12 years could have elapsed that quickly, but
Yeah, time does kind of flit by.
it does. I mean, I was a healthy individual back then and didn't have any grandchildren, and both of those have been negated now. So, uh, anyway, so why don't we start first by asking what are regular expressions and why would we ever want to use them, and what's the difference between a regular expression and Python's find replace normal string operators? So my last look at the find and replace string operators is that they don't give you flexibility with some text that only partly matches what you want to change. So I'm a system administrator at the cluster. Seems obvious, sort of. And one of the things that we have is we have a bunch of nodes that have names like node 200, 201, 202, et cetera, et cetera, et cetera. And maybe I want to do something to all the node 200s, but not to the node 300s or the 400s. And so the question is, how do I do a find and replace when what I want to find only partially matches all of the hosts in my node list? So that's some of it. The other, where it often comes up for system administrators, is in trying to parse and then report from logs on servers, and logs tend to be verbose. You might also need to do something like this if you were, for example, trying to extract data from some other service that gives you similar strings, but not always the same identical thing that you want to match. And then finally, what it does is it allows you to create match groups so that you can save the values of matched text and then use them later. So for example, you might get data where you get the IP address first and the node name second, and you want to flip those. That isn't always easy, especially if there's other information that appears in between them. So that's kind of when regular expressions are used. Old folks who learned Perl first, so we just use regular expressions for everything because in Perl it was pretty straightforward. Nothing special needed to be done. Using them in Python is more difficult. I'll also say at this point that regular expressions come in several flavors. So there's the Perl regular expressions. These are sometimes referred to, if you look in libraries, as PCRE, which stands for the Perl Common Regular Expression, I think, or something like that. There are programs sed and awk, which are commonly used by Linux system administrators, which have their own slight variations on the regular expressions. There are C++ regular expression libraries. They all share the same common architecture, but they may differ in sometimes subtly and aggravating ways from each other if you're used to one flavor versus another. So one of the links that's in the README file is to an online regular expression checker, where you can use that to sort of interactively figure out, okay, I don't speak noisy modem. How do I get this regular expression thing to actually parse this string and give me back what I really wanted? I didn't have those tools when I first started, so I ended up with two terminal windows next to each other, and then I would create the string in one, try the regular expression in the other, swear a little, change the regular expression and retry, swear some more, etc., until finally I either got tired of swearing and went and had dinner, or I actually managed to get the thing right. So the files in here are these. I thought that I would start kind of how I do these things with a simple one, and then we could go through and take a look at what does how does it work, and how my own personal strategy for trying to figure out what a regular expression should look like. So if we look inside the okay, so if we look inside the sample.log file, and y'all don't have to do this, but you're welcome to find it. One of the things that is going to be needed. Okay, so hold on, back up. I'll give you some background so you know what we are trying to accomplish with this log file. This is one of the ugliest programs on the face of the planet when it comes to logging, because they wanted you to spend a lot of money for their log visualization tool. So they kind of made it hard for you to figure out what the logs actually looked like. This is what a licensed server that controls the number of copies of a software package that can be run from the cluster at any given time. So what it does is each of there's what's called a feature, and the feature is the particular functionality of the software that's licensed, and each feature is licensed separately. The log writes at the beginning, it tells you using a line that looks like this, that it started, and it tells you the date. And it also tells you the time here. Okay, so here's the time and here's the date. You can see how old this is now, right? And then it goes and it does a bunch of other stuff. But you'll notice that in most of these lines, the date does not change. Or yeah, the date doesn't change, only the time. So one of the things that if I'm trying to track license usage that I'm going to need to do is figure out how to add the date to the timestamps. Okay, so this is all a bunch of, so I need the data that's in this line, and then I don't need any of this. This is not important to me. And then these are a list of all of the, whoops, sorry about that, Chief. These are a list of all of the features that are actually licensed. And then it comes down and tells me which hosts, which machines are actually able to check out licenses. And then finally, it gets down to the very first line where somebody wants a license for a feature. So I want to be able to get this line. The feature, as you can see, is going to change depending on what they're actually doing. The username is going to change, and sometimes the licenses will get checked out, and sometimes they will get checked back in. Okay, and then every once in a while, right? So we're getting these guys, and then every once in a while, we'll get a timestamp. And the timestamp will be what tells us when the date has changed. Okay. But the timestamp occurs sporadically It doesn't happen nicely at 11:59 or 12:01 or 12:00. So we're going to have to do some jiggling on the data to try to figure out, okay, wait a minute, if the last timestamp was greater than the current timestamp, that means we had a day turnover, right? Because 11:59 is definitely going to be greater than, we hope at least, that there's not a whole day that went by and that the next license chime out is 2 days later at 11:59. But if that happens, we should have had a timestamp. So these are all the sorts of things that had to go through my head when I was thinking about writing up a script that would keep track of the licenses. So I believe that that's most of the things that I had to consider when I was trying to figure out what to do with these log files, so that we could get a report of how often were licenses checked out, how many were checked out at one time, who checked out licenses, which hosts were checking out licenses, all that good stuff. So anybody got any questions about why are we looking at this at all in the first place? And I know that was a lot, and I know it's not computer programming, and I'm sorry about that, but this is the best I could do. It's relatively straightforward for an example. So onward and upward.
I have one quick question on those timestamps. Will it just periodically spit one out during the middle of a day?
Yes.
Like the same one every now and then it'll just say, hey, it's still today.
So it doesn't really tell you it's today. All it does is give you the current date.
Right. I mean, it's so like that's what you're saying.
But
you gotta
run
keep track of those and
periodically.
make
So
sure.
I'm likely to have, if I remember correctly, somewhere between 2 and 4 hours. Every 2 and 4 hours, I would get a timestamp. I wanted to keep this sample log file sort of modest so that people could scan through it manually. You can also see that there are 2 different features, 2 different timestamps that are reporting the same data. One is being reported, this is the actual server program that's reporting the timestamp. And this one is actually then what's called a vendor daemon, which is sort of like a sub-process. And so this is generic software that the company sold to MATLAB. And then the MLM is the add-on piece that MATLAB wrote using this framework to track their own features, as opposed to some other vendor which would have a different set of features with a different set of names and a different set of restrictions and so forth. Okay, so this may come up when we need to parse these, because we probably only want to do this once. I forget whether I want to do it once or whether I don't care. So that's that. So I decide usually to pick the simplest thing first when trying to deal with regular expressions. So I'm going to take a look at this one, which is, this is the dev timestamp.py if you want to follow along. And this is trying just to parse that timestamp line. So there. So we have the timestamp down here. So this is what it looks like. Anytime you're wanting to write regular expressions work on pattern matching. So in some ways, you can kind of think of this as a primitive form of artificial intelligence. And the way patterns are specified is usually by character groups and delimiters. And so the first thing that we would note is we definitely know we need to get the time. So time is 3 numerics separated by colons. we go to our handy dandy regular expression doodad and we look it up, and it turns out that the regular expression can be abbreviated as /D for digit, I think. Not decimal, but digit. And then the thing inside the curly braces says, how long do these things, what is its field length? Sorry, I should have had English for that. So let's see which one of these guys. Oh, I didn't give, oh yeah, I did. It's this guy, I think. So let's see what happens if I go to that. So one of the reasons that I included this is that it has a handy sort of a cheat sheet right here at the top of the page. So if you're wondering, well, how did I know to use D? I either look in the man page for regular expressions. I go to Python's site about Python specific regular expressions, which I find totally confusing until I read it 3-4 times and made lots of errors. But this is sort of the cheat sheet side. So D is any digit. I've got 2 digits, colon, literal. This is a literal. This is a literal, etc. So this gives it to me. This is all inside an R. I think the R in quotes, outside of quotes, means that this is to be treated as a raw string. So it's not supposed to try to treat it as any sort of fancy formatting stuff. And then the quotes include the regular expression itself. So this is all one regular expression. The space is also a literal. When you're writing regular expressions, beware of invisible characters that may come out looking the same. So that could have been a hidden tab. This is a W. So we come over here and we try to find a W. Do we find a W? We don't find a W. But I will tell you that the W stands for a word. And a word is basically any alphanumeric that is separated from other strings by spaces. Okay, so the word, and then the special plus character says there has to be at least one, but there can be more. So it's one or more. If we use a star, that's a 0 or more. Okay, and then if we enclose them in these escaped parentheses, that means that this is a regular expression save group. And the groups are indexed based on their position in the regular expression. So this is just a literal match. We're not saving it. This word we are saving. And wait, no, we are saving. Sorry. This is Python, right? So I think this is a save group. This is not a save group. These are literal parentheses. And then we have the word timestamp, and then we have some more digits at the end. So let's go see if I actually got that right. Okay, so yeah. So what are we doing? We have digits followed by a space. That gets us this. Then we have a single word enclosed in literal parentheses. So that will match this and this. And then we have the word timestamp, and then we have one or more digits separated by slashes. So that should be a regular expression that will work. I'm using Python 3.9 on the new cluster. So if I were to say, so the way some programs work is that they will compile or generate the actual regular expression into some kind of binary code, and then they will just use it on the fly without you having to do anything. Python wants you to try to do this compilation of it first. So obviously, before we can do anything in Python, we have to import the library. The Python library is RE. This, hopefully I haven't made too many typographical errors in my samples, will compile a regular expression called a timestamp. If I try to do timestamp, it will come back and tell me that it's a compiled regular expression. If I take one of these guys and say, what do I do here? Line equals, and I will paste that. So now I could try something like timestamp match line. What do I get? Oh, I probably want to have P equals. All right, so what do I get with P? So P comes back and tells me that, in fact, we did get a match. And it's got two saved expressions in it, the time and the date. And these are, you can refer to these using their index. And then you can do things like, let's do this, do this. See, Scott, you were talking about talking with your hands earlier. The virtual world, I now don't bother with my hands. I instead talk with my mouse pointer. So anyway, so this is just a very simple example of how you would actually use a regular expression to match lines from a file, save some information from them, put them into variables, and then spit them out either to a report or to some other format, etc. So, anybody got any questions? I turned the camera off because I'm going to take a bite of my lunch. So that being said, should be able to run this dev timestamp. And I think that I will get 2 lines of output because there are 2 timestamps in the log file. And there we go. So, anybody got any wonderful comments, questions, salutations, etc. about any of this?
I wish my 12-year-old code worked the first time.
Believe me, it didn't. This was supposed to happen 2 weeks ago. Okay. All right. So this dev feature.py is designed to parse one of these feature lines. All the same principles apply. We have the same timestamp. This time we have which program or subprogram, right? In most cases in these logs for checkouts, it's going to be the MLM. Then we have a field that is going to vary about whether it's checking a license back in because it's done using it, or whether it's checking it out because it's now going to use it, and therefore that license is not available for somebody else. There's the name of the feature whose licenses are tracked and are being checked out. And then we get the name of the user and the name of the machine on which the user was logged in and checking the license out. Anybody got any questions about like what this looks like? So we come back and we do the same thing sort of that we did before. I'm going to call it this. I put some stuff in here. Does anybody actually use or know VI? Okay, so one of the
I know
things
it,
that,
but I avoid it like the plague.
well, we are very complimentary, Patrick, because that's how I feel about Visual Studio. So one of the nice things about VI is that it allows you to do something called set list. I'm sure Visual Studio has this. And what that does is it puts visible markers where invisible characters are. And so you can see from this that there are invisible characters after this. And why did this come up? Well, I got a lot of bruising on my head and some missing hair from pulling because I did not realize until I did this that I could not match the host name as being the last thing on the line because there are two invisible spaces at the end of the line. So that's what this note in here is about. If you learn nothing else about VI other than how to get the hell out of it and how to turn this set list, set no list, it's worth it just for those two things when you want to try to figure out whether there are invisible characters bothering you. Okay, so very much the same thing. We're looking for the timestamp, the name of the feature, which we are not saving. We're saving the word that comes after the feature, so that's going to be our in out. That's here, followed by a literal colon. I'm not saving the colon, just the word. Okay. Then we have a space, and the quotes are literals, but we're saving the thing that's on the inside. And the plus sign says one or more of those. If I recall correctly, the capital S lets me get, it's a special class of allowing spaces, but not tabs or new lines. And then here we're getting the word before the at, and here we're getting the thing after the at. So again, if we come back over here and we do Python and we import RE, and then we have this MLM feature regular expression that we can use. And here I have a line for sample data. And you'll note that I'm including the double space at the end of the line. And then I can do this guy, create the P again. What am I doing here? P group I. Okay, so here I have a list. And then let's just do, so this is, yeah, I'm not sure why I put this here, but this would be a way you could use the P group I to go through and append each of the items to a list. So if we do this, then if we print data, that just shows you all of the fields that we saved. This is just a handy way of checking, and you'll see that it's a list in a list. So that would potentially allow us to process this. Each log entry is going to be an item in an outer list, and then each entry itself is a list of the things about the license, whether it was checked out or checked in or not. And then this would normally be done inside a loop, but we're just checking on things. And so we would do something like this to make sure that we could actually, we had captured all of the right things, that we could put them into variables, and that we could generate some kind of a report. And typically, I find I spend 20 to 30% of a coding project formatting strings for the people who aren't programmers that ask me to generate the report, who sometimes then never look at it. So anyway, that's how that goes. So that gives me everything I needed to know to make sure that I had actually got this regular expression string correct. So we could see this. So the regular expression pattern would be everything inside the quotes. And then down here, we would put in something for it to actually match. And then it says it did actually match. Now, if I were to change, so if I do this, it no longer matches because I said that that would occur at the end of the line. Whereas if I put the two spaces in up there, it does. Or down here, if I delete the two spaces at the end of the line. So this is also a good handy reminder to people that when you're reading data out of unknown sorts of files, you might want to use think about using your lstrip and rstrip or your strip command to strip white space from the beginnings and the ends of lines, unless they are actually going to be semantically meaningful. So for example, if you were writing a program to try to parse a Python script, you would not want to strip the white space at the beginning of the line, because that's actually an indicator of the indent level, which will tell you whether you're inside an unclosed loop or a function definition or so forth, or conditional, right? Similarly, if this were a make file that you were trying to parse, you would definitely not want to strip the tab characters if you were trying to figure out where recipe boundaries were. So that's basically that. And then the full-blown example is this REXP. And I will, as one of the most annoying math teachers I ever had used to say, the proof of this is left as an exercise to the reader. So just go through here and sort of make sure that you know what each of these is. And then the rest of this is just a relatively simple example of what an untutored programmer might use to try to make a thing that would print out a running count of the features that have license checked out. And every time a license is checked out or is checked in, it will tell you how many are still out. Okay, so effectively what we're trying to do here is to get a running count of the number of licenses that are in use over time. So anyway, and so yes, I sanitized this from my own error messages. And so what can we do here? So if I were to try to do that, I would say Python RE example, and it would come in, and that script prints something that looks like this. Okay. So what do I put in? This is also sort of, and again, this is my gray-haired, opinionated approach to data handling. I like to put in things, okay, so I can verify the start date. I can say, when did the data end? I can say, how many entries did I actually capture? Because these are all things that I can easily verify manually to make sure that I'm not missing things when I'm reading the data. It's always a good idea to look at the first few lines of data that you capture out of a really huge bunch. I didn't bother putting it in here because, like I said, this is an example. So I would do the same thing to the last lines. It's generally my experience, if the first few lines and the last few lines are correct, it's unlikely that the middle lines are going to be all screwed up. Unless the count is wrong, okay? And then this is printing then what we sort of wanted as a summary. And then if I remember correctly, did I? No, I did not. Okay. I used to have in the full version of this, I had a thing that would actually then print the running counts as it went by, but I took that out as just being too much garbage and would get in the way of seeing how the regular expressions would work. So that's the end of the snake portion of this little talk. I thought it might also be useful for you to see that has anybody actually used a program called SED on Linux? Do you know what it is?
Occasionally, but
Stream editor
yeah.
Yes.
or string editor.
Yeah, it is Stream. So what it is it's a tool to edit lines of text as they go by, and it has its own syntax for regular expressions. So this is just a long explanation of, if I'm on a node and I want to know about what network connections it has, I can use the IP command. That will show me all of the defined network interfaces. SED is a stream editor. It deals line by line, so it doesn't like working across lines. If you take the output from something, you can put it into a variable, and that will take multiple lines. And it is the nature of saving things into a variable that they all become one line. So by saving it into the variable, I have now taken multi-line output and converted it into a long, ugly single string that looks to me like, oh my God, if I have to get something out of this, a regular expression is really going to be what I want to use. And then after lots of explanation about how and why I was looking for these things, I finally came up with this, which I will take out of here and put over here. Did I not get that right? Did not get that right. Come on, guys. Okay.
Those darn mouse buffers don't always work.
Yes. The Mac is irritating on the days when it isn't better than a Windows machine. Okay, it's not like I have any
The
opinions.
bias isn't there.
Yeah. My completely unbiased and objective opinion. So this is what a regular expression in SED looks like. And you can see why I get confused, because here the backslash parentheses are the save, which is the reverse of Python. And what this is doing is this is sending the string that we saved in IF to SED. So this generates the stream. The stream goes to the stream editor. The S/ says this is the beginning of a substitution. This slash here is the end of the match sequence. And then this stuff at the end is the substitution text. And then the final slash is the end of the substitution text, and that all gets wrapped in quotes. Okay, so what are we doing here? In this particular context, the caret or the hat signifies the beginning of a line. So we are matching. This is a character class that says you're matching digits from 0 to 9. The backslash plus is like the unbackslash plus in the Python example, which says there has to be at least one or more of them. Then there's a colon literal followed by a space literal, followed by at least one word. And because this is escaped, parentheses, this is being saved into a match group. That will be the first one in the index. So that's corresponding to this guy out here. The colon is again a literal. What is this thing? So I'm matching a space, and then I have a character group inside the character group. This does not mean beginning of a line. This negates the characters that follow it in the character group. So this says match anything that doesn't have a colon in it. So we're up to here, and this is where we're looking, right? Because we got to this point, and so here we are. So what this is trying to match is this space, and then everything up to something that does not have a colon. Oh, yeah, there we go. So that should get us up to, it gets us to here. And then it says, okay, look for the specific text link ether. And then here it says, now I want anything that's got digits, lowercase letters, or a colon in it. Save that to group 3, because I saved this stuff, I guess. And then here, this is a space, and unlike with shell globs, the dot matches any character, and the star says 0 or more of the preceding character group, in which case the dot is the character group that matches anything. So dot star is not like on a shell glob where the dot is a literal and the star is anything after. This is actually saying 0 or more of anything. And so then if we run this guy, it takes this mishmash of stuff and it prints out just what I wanted, which was the name of the network interface and its MAC address. So that's the end of my circus act. If nobody has questions that need the screen, I will put the pony back in the stall. Going once. Okay. You can stop recording now, Pat. Unless there are questions.
Well, I didn't really have a question. It was more of a comment.
Go for
I was just trying to think cases in which regex would struggle or not be ideal, apart from obviously for unstructured data or for text that where we didn't consistently have similar printing output to filter the file and whatnot. So I guess what I was thinking was, would it be inefficient for parsing highly nested yet structured data, JSON, XML, HTML files? Because I was thinking, based on what you were explaining, that it would be hard for regex to parse through nested data structures, right? Because the depth and format may vary.
But you could,
Um,
if you'd work from the middle out, I think, wouldn't you? You'd find whatever the repeating structure might be and say any number of those, match any number of those between these other things.
Yeah, I
Yeah,
suppose that could
that's
work.
essentially what what you're looking for, yeah. For things like JSON and
What about the
YAML,
case for, and I guess I was a little biased because I was thinking of HTML documents specifically. If we're trying to parse an HTML document to extract tags or attributes.
tags and attributes always have some kind of an identifier attached to them.
Mhm.
So there will be tags that have a class equals inside, for example, or there will be a span something which has got a name in it because they have to have a beginning and an end. So you're unlikely to be able to use regular expressions to parse the whole file, but you can use Python to read the file, and then you would use Python to indicate how would you know where the beginning of a group begins. And then you would set a counter for that that says, okay, I have an open span now. And then you would use the regular expression perhaps to parse the attributes that are inside the span tag. And then you would have Python go until it finds the closed span, the nearest closed span tag. And then that would give you the rest of the text that's in there.
Gotcha.
Okay. I don't know of an HTML library that's like, the JSON library where it knows how to parse stuff like this.
Yeah.
JSON maps really nicely to Python dictionaries. HTML had way too long a life when it was very unstructured and lots of tags were optional, and others could say that it had a very short life, and now it has so mutated that it doesn't look anything like HTML again. God forbid Microsoft got their fingers into it and started trying to write HTML from Word.
There were people battling for like, how do you center something? Well, you put it in the
Right.
tag, you put it
And you
inside
got-
of the thing. It's like there's different ways to do the exact same function.
Right, exactly. So, yeah, that's going to be a problem no matter what. And so you kind of have to look at it in the broader context. If you could do something for HTML like you could do for YAML or you could do for JSON, where you parse out the structuredness of the unstructured data, then you write a program to deal with finding the nesting level that you want to get to.
Yeah.
And then at that point, the regular expressions perhaps become much more useful.
That makes sense.
Yeah.
In some ways,
regular expressions go back to, I mean, they were invented about the same time that C and Unix all came together at the same time. I mean, these things all have 50 years of history at this point.
Yeah. And I mean, in a lot of ways, the hint to that is embedded in their name, right? Regular. So what it's looking for has to be regular.
Yeah.
So you have to get your data to the point where there's something about it that's regular. So you could use regular, for example, you can use regular expressions as a nice way to figure out what a closing tag is actually closing. Because the regularity is going to occur with the open bracket / followed by something, followed by a close bracket.
Yeah. I wonder whether they're like leveraging regular expressions under the covers for a lot of these, syntax aware editors and things that highlight, groups or does auto indenting or any of that stuff. They're saying, well, this is, how do I take a random string that somebody banged in on a keyboard and, sort of pretty it up or display it with, keyword recognition. I'm guessing they're doing something with regular expressions under the cover.
It's quite likely. As you said, the regular expression libraries have been around for 50 years. And things that have been around that long have had an awful lot of people trying to figure out how to make them go faster.
Yeah.
They've also,
on the other hand, like as you also said, that standards are great because there's so many of them. The fact that SED uses a different convention than Python than you might find in something else.
Right.
Regular expressions are a concept with different implementations.
But within each library,
they're consistent within each library.
They've been very well optimized, and you can bet that the only bugs remaining are really obscure.
Indeed. And I have used SED is great as stream editor. If you if you have a bunch of data that's got to have, I need to change all of these to all of those. I just take the whole, could be gigabytes of data and just pipe it through SED and, look for whatever it is that uniquely identifies the thing you want to change and edit that stream to have the new character, rename this to that.
Yep.
I've used that many times it's super quick. And it's not programming, it's just command line pipes.
Hey, that's programming.
But it's not compiled Fortran or C it's shell scripting.
Right. Right.
As we learned, I think the previous one of these seminars, there's a whole bunch of things that people consider to be languages. Excel is a language, apparently.
Well, so is shell scripting.
Yes, shell script is definitely on the list.
But yeah, this is a good time to remind ourselves of the Unix philosophy, which is to write small, fast programs that do one thing. And then you use the pipe to combine them to do many powerful things.
Indeed.
And God, I've looked at some of the early startup scripts for Linux systems, and I really have to marvel at the brains that could write some of those things. They do incredible, weird stuff with shell scripting. Anyway, I was really glad that I did not have to write init scripts for Sun as my first job.
So Bennett, FYI, there is a HTML parsing library. When you asked about that, I found it. I just Googled it and I put it in the chat. It's called html.parser.
There you go.
Just like JSON. Yeah, I didn't know either. So when you queried that, I was like, I wonder. And
I figured there had to be one.
Me
right?
too.
It's not like this is going to be an obscure thing.
How useful it is probably depends on what vintage of HTML you're trying to feed into it.
Right.
Yeah.
Don't forget, there's also, that's not even a library. There's just a program called Pandoc that will attempt to convert documents in one format to another format. Yeah. As with any, whether it's an OCR, not the other OC. The OCR.
Optical character recognition?
Yeah, as opposed to obsessive compulsive.
Yeah, I know.
So anyway, but OCS has the same kinds of problems that something like Pandoc has. They're imperfect, so convert but check.
Yeah.
So yeah, I think to answer your question, Sharia, I think some combination of like the hierarchical parsers, like the HTML parser and JSON, to get to the individual pieces, and then regex to do the last bit is like the correct way to do it, or define correct would be a good approach. Let's put it that way.
One recommended process.
I think the reason that question came up was really I was trying to compare the pros and cons of using or trying to use regex compared to useful pre-established libraries like Beautiful Soup. That's already a great web scraping tool as well as widely used for HTML and XML documents. So definitely good to understand because I can expand this coding knowledge somewhere else.
Mhm.
And yeah, just
Yeah.
application wise, I appreciate that a lot.
Mhm. Yeah, I think the answer is often both because one thing will like get you down to like a smaller piece, and then Redx can finish the job, the customized part. Yeah.
I think I've most often used regular expressions when I'm trying to like suck in a subset of a whole bunch of files. It's like you use regular expressions on file names. It's like, a dash followed by some number of, maybe a date stamp, followed by maybe I know this next set of tokens is going to be the scenario identifier. So, we use regular expressions to, pull some subset of thousands of files into some processing.
Right.
All right. Well, we're at the top of the hour, gang. So thanks for sticking around, and
It was good.
we'll see you in 2 weeks. Take care, all. Thanks, Bennett.
Sounds good.
Bye.
See ya. Thanks.
Bye.
Yeah, thank you all for not
Thank
falling
you.
asleep.